Exception reporting and compression testing offers you the opportunity for maximum efficiency with your pipelines. The idea is to only store meaningful data in the PyData archive while discarding all the noise. Now, although PyData archive is capable of storing enormous amounts of data, it is important to store only this meaningful data in order to make your PyData archive run more effectively and efficiently as it can. So, have you ever refreshed a PyTrend only to see some of the data points disappear? What you're seeing is the effect of exception and compression. But you don't need to fear, because the fidelity of the trend will be preserved with the points that are kept and stored in the PyData archive as shown. In this video, we are going to understand the workings of these two processes, namely exception testing and compression marking. So first off, why store only meaningful data? So the first one is a bit obvious. It is disk space. You will take less disk space if you only store meaningful data. Next is the network traffic. With properly tuned exception and compression setting, there will be less data sent over the network. This will happen when the original data is sent from the Pi interface to the PyData archive. And whenever a client such as Pi Process Book or PyData Link calls the data, we can significantly cut down the network traffic load with properly tuned compression and exception settings. And the last reason is performance. Storing excessive data in archives is extra work for the PyData archive. And whenever clients call for big periods of archive data, much of the archive data is likely to be read from the hard disk. This is a very expensive operation, especially for bigger chunks of data. And lots of meaningless data equals slower client read times. So if you store only the meaningful data in the PyData archive, then PyData archive can retrieve bigger time ranges of data faster, giving you quicker access and as well as maintaining a happy PyData archive. So as we know, there are two different tests which we perform, namely the so-called exception and compression. So let's start with exception. Exception reporting takes place on the Pi interface before the value is actually sent to the PyData archive. So what we are trying to do is remove the noise. So by doing so, we are significantly reducing the network traffic between the Pi interface and the PyData archive. So to understand, so here I have a thermocouple monitoring temperature, and this thermocouple has some instrument precision, where anything that falls within the instrument precision is really the noise. So in this case, I have point A which is coming in, point B is within the deadband, so we don't need to store it or send it to the PyData archive. Point C is also within the deadband, and we have point D which goes outside the deadband. So in this scenario, we are going to send point A, C, and D to the PyData archive from the Pi interface. So what is great about exception testing is that it allows us to define a deadband to reflect that instrument precision. And what is more, we can individually tune all Pi tags to have their own exception setting. So the Pi tag attributes that define exception with regards to the Pi point attributes are: one is the exception maximum, which defines the length of time we can go before we actually report a value. Because if all the values are within the deadband, no data is going to be sent to the PyData archive. So as to avoid that kind of a situation, we define an exception maximum. And the other parameter is exception deviation, which basically defines the deadband or the width of this deadband or instrument position. Next come is the compression marking test. This is a more thorough test that defines which data is stored in the PyData archive. Unlike exception, compression can have a slope, and we utilize the so-called swing door algorithm. And here too, in terms of defining compression on the PyData archive Pi tag attributes, we have compression deviation, which defines the deadband. There is something called a compression maximum, and as well as we basically take care of the slope of the data using the swing door algorithm. So if I am considering Point A is the first point. Point B, C, D are within the deadband. We don't need to archive it. Point E is the last point, and point F falls outside the deadband. So in this case, what we are going to store in the PyData archive are points A, E, and F. So at a later date, if we basically want a PyTrend for this time range, PyData archive is going to be utilizing interpolation to based upon the points A, E, and F to report the PyTrend. Now, unless you are using PyBuffer subsystem on the PyInterface node to buffer data, compression testing is going to happen on the PyData archive. But if you are indeed using PyBuffer subsystem, then compression testing is performed on the PyInterface node before it is sent to the PyData archive. This is important in the case of especially PyData archive collective, so that both members of the collective have the same data. So the idea is to store only the meaningful data without losing any meaningful fidelity in the information. Since every sensor and PyTag are different, it's important that you're comfortable with the mechanics of compression so that you can confidently set your settings, namely the compression deviation and compression maximum, to match what is appropriate for you. Next, it raises a very important question. When is it appropriate to turn off compression? Well, OSIsoft generally recommends never turning off compression, but there might be some kind of few scenarios, such as lab values or manually entered values, totalized points where every point is significant, and there could be some kind of governmental requirement where you need to archive all the data which is being collected. If you turn off compression, then all exceptions are archived. A suggested better option to turn compression off completely is to set compression to on, but to set compression deviation to 0. This means successive identical values will not be archived. So in short, as a summary, in this video we saw why is it important to have the so-called exception and compression testing, and its settings are set on the PyData archive attributes itself, and how we implement the basic exception and compression testing.